Here goes. Okay, so this in this week we are like basically I have like a couple of articles that I want to read from this thing, but either that or we can go back and look at our server and then see if we have any articles from last time that we want to continue. Right. We saw the scheduling article from last time, but I don't know if I want to finish that because yeah, a lot of it required us to spend way more time. I don't think we can finish that in like 20 minutes.
No, 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 no,
So
no,
yeah,
no, no.
so so the couple of things that ones I have are one is how Figma's database team lived to tell the scale. So this is how Figma handles their Postgres and how they shard their database and all of that. I think so. That is one. The other was this is talking about like what if we make URLs immutable, so like a what if kind of an article, right? That is one. This one I liked a little bit. So it's a very small one, but this is from Phil Eaton. Phil Eaton is like is a really good database and a distributed systems person. He has, I think he also runs a book club and a cohort of some sort, if I remember correctly. But so he has a lot of really good articles whenever I come across them. So he talks about Zig, Rust, and like I think some trade-offs here and there he also talks about, but it's not a very long article. But we can give this a read. But yeah, if you don't follow him, you should follow this guy. Really good. The other one is a JavaScript nightmare. Some people who don't use JavaScript say it's a nightmare every day, but
No, no, like I have started using Java and like I have started feeling like JavaScript is nightmare.
is it? That's what I'm saying.
Yes.
That's what I'm saying. I'm
Like, I'm
telling
a
you,
Java guy now.
you're a Java guy now. Okay. Yeah. Other
Uh,
than yeah, but I mean that's probably when you go from somewhere like when you have like better. I don't know. I don't know if I would
नॉवेल्टी
compare that
फीलिंग
with Java, but yeah, okay.
नॉवेल्टी फीलिंग होती है हर नई लैंग्वेज की यू हैव टू लेट इट सिंक इन एंड देन आफ्टरवर्ड्स ना फिर वो कंपेयर करने का I
like
often do
today
this
is my
with a
honey,
lot of
like 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 around this time it is my honeymoon period
okay so you're
with
past
Java.
it right you're past it now
Yeah. So, yeah, I don't know. For me, it was okay. It has its own quirks. It served well, but I'm on to greener pastures right now, trying to not do as much JavaScript as I want to. But yeah, I guess Rust is my newfound love, I guess. So but, I'll keep talking about it for some time until that honeymoon this thing wears off, and then maybe I'll go on to another language. Yes. Uh, but yeah, so okay, so which one? I think we should look at the Figma one and this one probably, or which one do you want? Do you guys want
But
to?
like how bigger is that Figma one?
Figma, not
fairly big
that fairly big, is it? Yeah.
20 minutes में नहीं होगा ये
हो जाएगा. We'll try to read it
And
fast.
नहीं रश नहीं
It's
करना है ना
no, it's because it's
that's not possible because we'll discuss things and all.
डिस्कस
Let's go
करोगे
over
तो
that Zig one only.
जिगन
okay.
वाले
Zig
करते हैं
one is, but that means that you need to have some context of Zig also, right? That is
और
also
जिग का
important.
कॉन्टेक्स्ट नहीं है किसी का बस
Has someone worked with Zig?
No, I just know
नहीं
what it is.
I just watch Primagen and I know Zig
Yeah.
Okay, that kind of context, then okay, then this is fine, right? So then we can
we'll
look
see if
look
you
at
don't
this.
understand they will like probably
I don't think he's
okay
talking about anything in depth here. It's mostly like surface level, I think.
yeah.
But okay, we'll read this. See if this is a good start. So okay, having worked with a bit of Zig, Rust, Go, and now see, I think there are a few common topics worth having a fresh conversation on: automatic memory management, standard library, and explicit allocation. Zig is not a mature language, but it has made enough useful choices for a number of companies to invest in it and run it in production. The useful choices make Zig worth talking about. Okay, so when we talk about Zig, there's this podcast that Ninad shared last week. Right, Ninad? It was last week, right? I
Yeah.
gave that a listen. It was really good. So I think if I can just paste that in chat again, but it is developer voices and where they talk about how Zig's core use case was interop with C to a point where it is better at C compilation than the existing C compiler itself. So the approach that Zig takes, it basically it has its own versions of it doesn't like using like Rust or does or Go does. It doesn't depend on libc or your operating system's versions of C. They have their own ways of directly doing syscalls to your operating system. So they have written like you have a way of directly doing syscalls for Linux, for example, right? So you can directly call those APIs instead of going through C, which is the route that Rust and Go take, right? And because of which Zig is now actually now used for cross compilation at different places. Like I heard from the podcast that Uber is using it for cross compilation and all of that. So it's like a valid use case for Zig right now is cross compilation. Like not even if you're not using the actual language for production, they are using it like as a compilation target of some sort. So yeah, if you can listen to that, it'd be great. That's my I have not looked at Zig beyond that, but maybe I should. Go and rest on mature languages, but they have more made questionable choices that seem worth talking about. Okay, let's see what is questionable, right? All of these languages are developed by highly intelligent folks I personally look up to, and your choice to use any one of these is certainly fine, whichever it is. The positive and negative choices particular languages made, though, are worth talking about as we consider what a systems programming language 10 years from now would look like, right? It's just like a future-looking perspective, right? So my perspective is mostly building distributed databases, and so the points that I bring up here may have no relevance to the kind of work you do. That's all right. Moreover, I'm already aware of one of these opinions are not shared by language maintainers, and that's okay too. I'm not writing to convince anyone. Okay. So automatic memory management, right? So this is a hot topic because fundamentally all of these languages differ this in like huge in one large aspect, right? How Zig does it is is different from how Rust does it. Is very different from how C does it. Is how different from very different from how Go does it. Right? All of them have very distinct ways of doing automatic like memory management in some sense, right? So specifically when they say automatic memory management, I think okay. So let's see. One of the bigger issues with Zig is that it does not support RAII. So RAII is basically resource acquisition is initialization. So it's basically what that means is let's say you have a scope, right? Like and that's particular scope. I'm just saying scope. It can actually it's much more than that. But imagine like you have like a block scope of some sort, right? When that scope ends, if you have initialized a variable in the start of it, and after that scope, if there are no references to that particular variable, the memory for that is automatically dropped. So it's basically like calling drop or free in C, right, for a specific reference. So that's basically what RAII is, right? So you can but the thing is they use a pattern similar to Go, right? I think Go has this defer, right? So defer cleanup at the end of a block, but so you have to manually click, do defer. I think that's right? But only RAII will allow for smart pointers and automatic reference counting. So automatic reference counting is basically the compiler knows how many times you have this reference for a particular how many times you've used the reference, right? So that's what is automatic reference counting. RAII is an excellent option to default to, but in Zig you aren't allowed to do that. In contrast, even C supports automatic cleanup via compiler extensions. Okay, so but most of the time arenas are fine. I don't know what arenas are. Postgres is written in C and memory is almost entirely managed through nested arenas. Okay, that cleaned up when some subset of a task finishes recursively. Zig has built-in support for arenas, which is great. So does someone? Okay, I think I'll pause. Someone know what arenas is?
No.
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 Okay, so then we'll have to Google it, I guess. Zig Arenas.
I think memory arenas is a general concept, which I think I read that Go is. I don't know what it is, but I read that there's a proposal for Go to add it to even improve performance more. It's not a Zig specific thing, I think.
Okay, it's not a GC. It's not a GC thing. I think I'm just sorry for the white flag.
Just open that image in a new tab. I think it will fix it.
Okay. No, it doesn't.
Oh, PNG.
Fine.
Okay.
I'm going to burn your eyes now. Okay. So allocate, arena allocator. This is not useful. Okay. I think I'll redo it. This is one of its 6 built-in allocator. It takes another allocator and wraps some code around it to allow you to allocate memory without the need to free them individually. Every allocated memory will be freed at once when you call allocator.beInit. So let's search for the term arena. Doesn't it tell you what an arena is, right? Does it?
I just, I just pasted a piece of text in the chat. That's what it means.
Okay. The large
No,
contiguous
something that
memory
is-
that allows you to allocate once and then use manage manually by handling out parts of that memory. Makes sense. So it's basically a slice, right, of some sort, right?
It's a kind of a ring fence that you create around memory, saying that, it's like just imagine it's like a large piece of land which you are given to, do your agriculture on. It's like that. I mean, it's an allocated piece of land. Within that, how you manage your memory is what you can do whatever you want.
Okay. Basically bounds, right? You have memory bounds of some sort,
But
and
it's
then
it's a bound.
yeah, okay, makes sense. Okay, so that's what an arena is. Okay. Okay, let's go back. Okay, up until now, I think this is we talked about RAII, we talked about this thing, right? Do someone want, like, should I talk about RAII a little bit more, or is that okay? We can if we want.
We can talk. Yeah, go ahead.
Yeah. So okay, so let's look at RAII. Just one example of what RAII is, because it makes it much clearer, right? So okay, I'm showing you some Rust code, but I'll try to be even if you haven't read Rust, I'm trying to make it as obvious. Okay, okay. So so when you say box, right? Box basically in Rust means you put some data on the heap instead of putting it on the stack, right? Like, so box is basically a wrapper around your data that allows you to allocate something on the heap instead of the stack, right? By default, like for example, if you like let's say if you do let a equals to 20, right? So this is going to allocate on the heap because this is a straightforward integer, right? But if you want to allocate something else, like by default, like Rust prefers stack allocations over heap allocations, right? And if you have to allocate something on the heap, you have to make it explicit, right? There are other languages that actually prefer the heap over the stack, right? But for Rust, right, since they prefer the stack over the heap, so that's the first thing that is important, right? So let's say you allocate an integer here, so they are saying the box one, right? uh, Actually this is not the right example. Let's look at this one, right? So so box 2, they've created a new integer that they've put on the heap. So this is on the heap right now, right? This is a nested scope, so this is also a scope. So main is also a scope, right? So they've created a nested scope, but you can think of this as simple as like an if or if else or something like that, right? So something that's between these curly braces, right? So at the moment this scope goes over, right? You can't, if you refer to box 3, it will throw a compiler error because it is initialized over here. So the initialization is happening here, right? And you are trying to access it outside of the actual scope that is it, right? So for you to actually do it, you need to put it move it to a above scope, right? Move it to a much larger scope, right? So that's when you will be able to access that what do you call variable, right? And if you do so if you try to access box 3 here, it's going to fail, right? So that is what RAII here means, is this resource initial acquisition, right? So you're trying to acquire this resource, which is trying to acquire a box of that basically a heap allocated integer, right? So that is your resource acquisition, that and the initialization is happening over here, right? So this is RAII, resource acquisition is initialization. So the moment this scope goes out, you can no longer use that particular reference or that variable. The compiler is going to throw an error. That's a simplistic way of looking at RAII, right? C++ has this. I think it was this concept itself was introduced in C++, and then Rust sort of ran with it. This is sort of the main memory model of Rust, and whenever someone talks about RAII, this is probably what they mean, right? Makes
Borrow
sense?
checker is based on RAII only.
Right. Yeah. Correct. And the entire Bora checker entirely follows these a couple of rules that, along with RAII, it has some ownership rules, right? So Bora checker's entire purpose is that there are like 3 rules, right? Okay, we are learning Rust now. So this is now a Rust video, but yeah, not the right look at. Okay, so I'll finish this with this the 3 rules, and then we will go back to our. Da, da, da. trying to find. Okay, all comes. I'm trying to look. Yeah, these are 3 rules. So each value in Rust has an owner. So in this case, right, previously you saw the box 3. The box 3, the variable that's called box 3 is becomes the owner of that particular allocation, right? So a variable becomes the owner, right? So and at any point of time there can be only one owner of a particular resource. So in this case the resource is against the heap allocation that we saw earlier, right? So that can be only one owner, and if the other if you need to basically have the memory be used by someone else, you can either pass it as a reference or you can clone that particular this thing, right? So there are 2 ways of doing it. So when the owner goes out of the scope, the value will be dropped. So this is where RAII is. So this is the third point is where the RAII is enforced. Basically whenever the owner, which in the other case we saw it was the variable, right, box 3, so that went out of scope, and then the value was dropped. So that's the third. I think it's clearer now, hopefully, right? So this is a simpler example. So s equals to hello. So before this slide, it's not valid to use s. After the scope ends, you can't use s, right? So basically this is your scope. This curly brace is your scope, right? So when s comes into scope, it is valid, but it remains valid until it goes out of scope. So this is the sort of the main thing that the borrow checker does. There's a lot of different other things that will check, but the whole point of the borrow checker is to make sure that for anything and everything that you pass, anything that moves around, any function, argument, whatever you work with, it needs these 3 rules to always stick, right? And if you're doing anything that is beyond these rules, you're basically writing unsafe Rust. Unsafe Rust is terms sounds bad. It's basically writing Rust with manual memory management, without RAII and without all the memory automatic memory management that Rust does you. If you say if you're going to write like imagine you're writing C where you have to manually manage memory, right? So that's what unsafe Rust means, quote unquote. Right, it's not bad. It's there for a reason, because you in a lot of different places, like say for example in embedded, you need manual memory management, right? So in all of those places it's useful. I think that's enough about RAII. Any questions?
Right.
Cool. Okay, so standard library. It seems regrettable that some languages have been shipping smaller standard libraries. Smaller standard libraries seem to encourage users of the language to install more transitively unvetted third-party libraries, which increases build time and build flakiness, and which increases bit rot over time as unnecessary breaking changes occur. Okay, people have been making jokes about node modules for a decade now, but this problem is just as bad in Rust code bases as I've seen, right? Because the model that Rust has is very similar to what Node has in the JavaScript ecosystem. They have something called crates, and the same problem is there because it's a one-to-one functional model there, because you have the same set of anybody can publish a crate, and then you can pull in crates, and then crates have smaller crates as dependencies and all of that, right? So the same problem they have in Rust, and to a degree it happens in Java and Go as well, though their larger standard library allows you to get further in without dependencies. So this is so the trade-off here is basically Rust says that I'm not going to ship a lot of things in the standard library because they want to have a bigger community and all of that. But that also means that for like very basic things like JSON parsing, you have to depend on a crate. If you use Rust, you're using a crate called serde, right, which is serialize and deserialize. That's serde is the name, right? And but other languages might have it built in, right? So that's the or some way of doing it. I'm not sure if Go has it. Someone who writes Go can correct me. I don't know if Go has it in the standard library, but I'm just giving an example, right? You could think of things that you
JSON parsing exists by default in Go.
right.
You don't need. I mean, again, there are standard parsers, and again there are some advanced parsers of JSON,
Yeah.
which people have created, and those exist as what we call as the packages, right? Go packages, but yeah. So you're right. I mean, just curious. I mean, I did very basic stuff with Rust. Okay, I haven't really got my hands dirty beyond a point. Just trying to understand. In terms of the point that we were taking there, talking about the everything is a crate, right? Is it that some of the things that we would probably assume to be standard, for example, I mean, is if we have to run if we have to do some kind of a concurrent programming, Is that also create in Rust, or is
No,
it like,
that is part of the standard library.
part of?
So those are part of standard library. So the model is that you had some crates for that originally, right? But right now they have their own way of they have a way of doing threads and all of that. So all of that is part of the they have a sync. They have standard libraries that for all of that functionality. But certain things are still
Okay.
fragmented, right? So there are since say for example a good example would be writing asynchronous code, right? Like if you're used to write JavaScript, right? Something you have something like promises that are built into your language, built into your runtime, right? But for Rust,
Correct.
they have different standards of doing the same exact thing. They have something called Tokyo, which is its own async runtime. They have async standard. There's something called async standard, which has its own way of doing. It has its way of doing the same. Like what do you call? They have their own opinions of running how they want to do async, right? So all of these exist because I mean that's again a positive and a negative, right? If you want in some way that if there's an opinionated way of doing it, people prefer that. Some people prefer to have options, right? So it's just a trade-off at this
And
point.
how is the model working in Rust? And again, a very ignorant question this way, because I don't completely understand it.
Hmm.
How is the model working? Are they pulling crates into the standard library eventually, or is it more like,
No, yeah, that's what they're
they
doing. That's what they're doing. So it's not. It's a very open
that's what they're doing?
ecosystem. Yeah,
Okay.
it's a very open ecosystem. And even till date, there are
Mm.
in terms of community itself, they actually follow a lot of practices for just to make sure that they have like the standard library is usually very good in comparison. Whatever is there is really good. So they have some way of like pulling in. They pull very popular crates into the standard library. If they don't have like an out of the box solution like that, if I remember correctly, they have something about. Very recently, I saw that they had some concurrency or some concurrency related crate. I forgot what it was, and that also they pulled in from the ecosystem, right? So they do that. They do that as this thing, and I think it's a matter of time, right? After a point, you will have
No.
a large enough standard library to accommodate all of this, right? So I guess like in like 5 6 years maybe down the line, provided the Rust Foundation also has the Rust language ecosystem also has that mindset, I guess this standard library will become larger. But right now, this is the state they are still building. But Zig has a completely different approach. They are building everything from scratch. Their whole idea is that as I told you, right? They are building. They don't even want to depend on libc. That's how. That's
Mhm.
how much work there is for Zig, right? So they are only going to use their own code in most cases. And their whole I
And
think
that's a tall order. I mean, if they're completely doing away with any dependency on libc, right? That's a very tall order to really,
they're doing it. They've been doing it for a couple of years. I think they have full-fledged databases that are built on Zig. Like I'm hearing like Tiger Beetle, if I know remember correctly, that's built on Zig. So like people are using it, and
Hey,
I
can
think
you share the link for that? I just want to really
yeah.
look for it.
This is if I remember correctly. I think this was talked about in Primagen's this thing also, right? Someone can correct me.
Yeah, he gave a demo there. That's a good demo.
Yeah.
Sorry, who gave a demo of this?
The
His
C
YouTuber, Primagen.
yeah, but he gave it on this the CEO, I think, of this founder of this database actually mentioned it. But yeah, I'm hearing that this is like really
Interesting.
fast, has like good benchmarks and all of that. But again, I've not played around with it, so I don't know. But like there is ecosystem, like people are building like this tooling with it. It's just still not widespread, and their operating model is also very different from Rust per se, right? Like they operate on a model where it's not a foundation basis. So it's as a Zig is entirely they operate like a charity in some sense. So it's basically you have to work with that rather than you don't have like six corporations who are sponsoring Zig. It's usually like you have to when you're donating, you're basically donating to Zig for the language to grow, right? So it's a very different operating model.
Okay.
Yeah, but okay. So I think I'll finish this. So, but one goal of their package manager seems to be to allow the standard library to be broken up and made smaller. For example, JSON support moving out of the standard library into a package. I don't know if this is actually a planned direction. Uh, Okay, so I was just talking about Zig, and now they are moving their JSON support to a standard library out of the standard library. Maybe this is too heavy. I'm just thinking that like having JSON parsing in the standard library is like a heavy thing. I don't know. Maybe but that's why Zig is doing it. But yeah, so it looks like packages move in and out of language ecosystems based on size and or different things, right? Okay, so having a large standard library doesn't mean that the program shouldn't be able to swap out information easily as needed, but all that is required for the standard implementations to do is define an interface along with the standard library implementation. So the small size of standard library doesn't just affect developers using the language, it even encourages developers of the language itself to depend on libraries owned by individuals. Take a look at the transitive dependencies of official Node.js package like Nodezip, right? Uh, it is really the ideal outcome of a small standard library to encourage dependence in official libraries on libraries owned by individuals, like env paths that haven't been modified in 3 years. So basically Node.js, which is official Node, it depends on env paths which is owned by an individual, and that has been modified in 3 years, right? That's literally what they're saying. 60 lines of code. It is not safer at this point to vendor that code. That is, copy the env paths code into Nodezip, right? This is a huge problem in the Node ecosystem. Left pad, if people remember, so we had a lot of
I don't
issues.
I don't think like if something has not been modified in 3 years, that automatically means that it's not being actively maintained. It's just that it
What
might
about
be a very
security
small.
issues? What about
Yeah,
security
whatever
issues?
security issues have just not popped in 3 years. Like it might just be
Yes
that
and
case.
no, right? Yes and
60
no.
lines of code.
You still need a maintainer to be there.
Who is
I'm
the
not.
maintainer? I think that Array, he is a very famous guy.
Yeah, Syntasaurus is very famous. He generally updates his stuff, right? So after this, there's probably
That's not an
no
issue.
requirement to do it. But from someone who's not looking at it from like a different language perspective, this is very, what do you call, not might not be as straightforward, right? If you're like something, if you like basically you have core system, right? And you have that core system that is dependent on something that is owned by an individual, and it's been not been updated for a while. It's like from just the surface level, it seems bad, right?
What's the like acceptable duration for this? Like
I don't know.
at
That's
what
not.
point would you at what
Open
point
source is
would you go like,
exhausting.
okay, this is
Open source is exhausting. You can't blame maintainers for not maintaining stuff, right? So even if they are doing it for full time, it is not like nobody has enough right to say that.
no, because
Uh,
okay, disclosure, I might be in a position where I have not updated a library for months now, and
No, it's
I
entirely fine,
want
right?
to
Like
make like
as
what
long
do
as
you
your
think is
issues
the
are not overflowing, it's fine, right? So
okay.
if this had like a lot of issue count, then I would be worried. But right now, there's no issue
That's
count,
what I'm
right?
saying, right? Like, does he really need to update it?
Yeah, probably. I don't
This
think
argument,
this example is probably not the right
yeah,
thing
this
to look
argument
at.
that
Yeah.
it's not updated for a long time,
Yeah.
therefore it's not being
So
maintained properly.
it's not updated. It has a lot of overflowing issues. That's probably the bigger issue, right? Like I
Yeah,
don't think
that
this
might be.
specific library itself is a problem, but rather if you look at something where like we have some, if the node core depends on some library that has like some security issues and it's been not been updated, that would have been a bigger problem. But I don't think they would let something like that slide, right? Like because we have a lot of again, it's owned by a lot of companies right node in production, so you cannot, they won't be able to get away with that also, right?
Yep,
So
yep.
again, it's a blanket argument against not using individual based packages also, right? So that uh, again, sort of some bias in saying that you need a lot of things to be in the standard library always, but it's a trade-off, right? If you want to like so the trade-off here being, do you want to encourage a community or an ecosystem where like you can look at this as a flip side also, right? Node has a great ecosystem that even the core depends on individual packages. You can
Mm,
basically turn that argument around on its head,
yeah.
right? So the trust on the ecosystem is much higher, which again has the same problems, because when some maintainer is dealing with problems, or if if they have their what if their npm account is compromised, or if we have also seen in the past that maintainers going they're going on a rampage and then deleting packets, and all of that has happened in the, right? So
Mm.
same thing is happening in Rust also. We saw the same outrage in recently in Rust also, something similar to that happened. I think with Third, I don't remember. I think it was, I was just looking at, it was also discussed in Primogen's
It was more
video.
about the guidelines
Yeah,
regarding
yeah,
the
yeah,
package
yeah,
management.
yeah. But
Yeah.
I don't remember. But again, so it's very common, and it's okay. But
Mm.
the only thing is that it does not have to have a lot of issues, I guess. That's the only takeaway I would say.
Yep.
Yeah. So similarly, if you go looking for compression supported Rust, there's none in the standard library. You may notice that Flate to Rust under the Rust language space. If you look at its transitive dependency, again, Flate to Rust depends on Minis Oxide, which depends on an individual's, again, Adler that hasn't been updated in 4 years. So we can look at this, right? There are no issues. I don't see anybody complaining about
Yeah,
it.
that like, why are you complaining about it not being updated for 4 years if
Yeah, and
there's
it's used by
nothing to update?
260K people, right? So should
Yeah.
be fine, I guess. I mean, again, uh,
This
just
argument that it's not being updated for a long time
yeah.
automatically makes it unsafe to use is kind
Yeah,
of
that doesn't make a lot of sense in some spaces.
yeah.
But like, say for example, in like in a corporate sense, right? You might have compliance requirements. I don't know. Like they have something called component governance, right? So at corporations or I think even startups, I'm not sure. So they have something called component governance, but where every open source module that you take in, it is inspected for. It is inspected. This is actually one of the things that is inspected for, right? They look at how active this has been. Is it actively contributed? But they don't. I don't think it's the weightage is high for that. But if it has security vulnerabilities that are known and disclosed, right? Like if you run npm audit, for example, in the JavaScript ecosystem, you get like a series of security vulnerabilities. They if you are you have to get some sort of an exception for those, right? If you're using a component, an open source component at that, you'll have to get an exception saying that this is okay. I've audited this. This looks okay, and this looks fine to me. Or you have to get an exception saying that this will be fixed or something like that, right? So in those scenarios, I think probably you'll get an alert saying that this has been idle for 10 years or something like that, right? So it might be a red flag, but I don't know, right? I've not seen that play out specifically, that being a problem. But like if you take a cursory look at a package and it's not updated for a while, I think that is a
There's a bad
psychologically,
taste in your
yeah,
mouth.
yeah,
I get it. Yeah.
psychologically you feel like maybe I shouldn't go for this, or so go with something that has an active community, right? So like if it has a community around it, that's actually even better, right? It's just if it's under one person, I think that is a bigger problem, right? Because you are now relying on that maintainer not wearing himself out or burning himself out, right? uh, I'm seeing that play out in a lot of different cases where there's a maintainer who's very very active in an open source project for a long time, and then he needs a break, right? And then decides to not come back and update it. But there's already a lot of people who have come on board. But the thing is that the maintainer did not take any initiatives to form a community or like have a lot of encourage more contributors, right? Because it was a personal project, right? The problem is that the personal project started being used by a lot of other people that was not the original expectation, right? And then they do some things to fix the issues and all of that, but it still goes beyond a point where it becomes unmaintainable, right? And then they'll have to drop it, right? So those I think these are all those scenarios, or it may be the other thing is that it might never require an update. There's nothing that changed. It is pretty straightforward code, so nothing changed really, so there's no need to update. Both of those are possible, right? I guess the only thing that maintainers can do is try to form a community, and then so that even if this does come down to like basically a single point of failure, right? The maintainer here is the single point of failure. It can be, you can have a couple of other contributors who can step up and then take the battle, right? That's probably the only I think solution to this, I would say. But yeah, why not rent out this code is again trade-off. It's they want to have a lean standard library, right? But yeah, I don't mean this as necessarily constitute a supply chain risk. I'm not talking about left part. Yeah, so the pattern is sort of clear. Even official packages may end up depending on external packages, because the commitment to a small standard library means omitting stuff like compression, checksums, and common OS paths. It's a trade-off, and maybe makes the job. That's what they're saying, right? Like that's a trade-off, and maybe makes the job of the standard library maintainer easier. I don't think that's the ideal situation, is what he's saying. And dependencies are useful, but should be kept to a reasonable minimum. Hopefully, languages end up like Go than like Rust in this regard. Yeah, I don't know. So I'm assuming Go has a lot of standard built-ins. That's why it's good. So yeah, I get that.
Also has that route. It's, a lot of stuff is inbuilt.
That's good. That's good.
But what happens is that the same project ends up using the external implementation like Newtonsoft, and we also have system.json and system.text.json. And what happens is that it conflicts and clashes with all the
So
developers.
you're talking
like
about the C# ecosystems.
C#, yes.
Yeah.
So there's two deserializing libraries for JSON, and the new people always kind of fuck up with Newtonsoft JSON, and then it does not sit well with the way it
default
parses
code.
is different. Yeah.
Yeah, that's because C
because
Sharp did
that
not have it originally, right? And then they did not.
yes,
So Newtonsoft was
default.
the default, and then it became, I think, part of the .NET. Uh, I don't know which version of .NET they introduced this, but
I think 4. I'm not
four,
sure
four,
myself. But
probably, yeah, four.
probably.
Because I know that in 6 it is there. I don't know if a 4, 5, I don't know. Maybe I might again. I don't. I'm actually, like, even at work. I very recently started doing .NET, so it's not something that I have done a lot, I would say. So
Mm.
yeah, makes sense. So explicit allocation. When folks discuss the Zig standard library of requiring allocated argument for every method that allocates, they often talk about benefit of swapping out allocators. Okay, so here's the thing, right? Since Zig does not have RAII, right? So they need you to pass something called an allocator. So basically, whenever say think of a function that allocates an array, right? Or allocates like say you want to pre-allocate an array of length 10 or something like that, right? So if you have to do something like that, at least what I'm understanding or like what I've heard is that you need to pass in an explicit memory allocator function to that, and then that allocator takes control of that memory arena, right? I'm just trying to correlate concepts, might be wrong, but based on what I'm reading, that's what I'm seeing, right? So you need to take in an allocator as an argument, and then that allocator is what is responsible for handling that memory arena, right? So again, this is a very unique thing. So that's what he's saying, right? Both of these seem pretty niche to me. For example, in Zig you at Zig test, you are encouraged to pass around a debug allocator that tells you about memory leaks. But this doesn't seem too different from compiling a C project with a debug allocator, or compiling with different sanitizers on and running tests against the binary produced. In both cases, you mostly deal with allocators at a global level, depending on the environment you are running. Okay. So the real benefit of explicit allocations to me is much more trivial. You basically can't code a method in Zig without acknowledging allocations, right? So this is particularly useful for hot path code. Take an iterator, for example. It has a new method and a next method and a done method. Okay, so this is basically if you're used to iterators. Iterator is essentially it allows you to how do I put it succinctly? So an iterator is
Iterator
something.
allows you to iterate.
It allows you to write, right? Yeah, obviously, right? But think of an array, right? So an array has an iterator where the next method would return the next index, right? And the done would basically finish parsing, like iterating through the array, right? You can do this for not just arrays or like straightforward types. You can do this for your own custom structs or right. So but all you have to do, but what you have to make sure is that you have to write an extend an iterator, write an iterator that handles these next done and new methods, right? So that's how you write an iterator for that, right? So in most languages, it is basically impossible at the syntax or the compiler level to know if you're allocating in the next method. You may know because you know the behavior of all the code in next by heart, but that won't happen all the time. So what they're saying is, so at the syntax or compile level, you don't know that you are allocating in the next method. Okay. So if any memory allocation is happening, the next method is something that you won't know in. Okay, again, this is, I don't know. I'm not sure. Probably have to just agree with this, I guess. But yeah. So but that won't happen all the time. Okay, we'll take this at surface value, and then move on. So Zig is practically alone with that. If you write the next method and don't pass an allocator to any method or in any method in the next body, nothing in that next method will allocate. Right. So basically, what they're saying is, unless and until you explicitly pass in an allocator as an argument, you can be sure that saying that method is not going to allocate memory. Right. So that's very unique to Zig because it deals with passing an allocator as an argument. Right. In any other language, it might not be until you run a profiler that you notice that an allocation has been done. Okay. And now I get it. So basically, what they're saying is. So when you run a new when you do call the new method, right? It's basically a constructor, right? And you want to allocate memory in the constructor, right? So you have like a chunk of memory that is allocated for that particular iterator that you run, right? So basically your data structure has that some if it's an array, it's like a contiguous block of memory, right? That's allocated for you, right? And you iterate through all of the values, right? So what they're saying is for you to make sure that the next call is not allocating any more memory, it is not possible to do that in compile time. because like there's no way for you to know it, right? Like you can basically arbitrarily just extend the length of the array or just add a new element in the array, or you can do all of those things in the next method, right? But if you in Zig, unless or until you pass in the allocator, you can't manage that memory, and that's why it's easy. Like in some sense, it allows you to get rid of that issue, right? That you only allocate memory once in the new method call, and not in the next method call, right? I guess that makes sense.
Hmm.
Yeah. Okay. I'll finish this section, and I think I'll pause for if you want to discuss something.
No, we can continue.
Yep.
I'm actually trying to understand what's the point that they're trying to make.
Okay. On the other hand, for all the same reasons, writing Zig is kind of weird because everything takes an allocate. Right. Again, they're not. The whole article is trying to compare and contrast the decisions taken in these languages and how they're affecting them personally. Right. Right. So as someone who
Right.
I think Phil Eaton is an incredibly knowledgeable person. Right. He's written. I think he has a book about. Interpreters, I think that's it, right? I forget if this is the same person I'm talking about. I don't know if that's the same person I'm talking about. No, that's not I'm talking about a different person. I'm sorry.
It's Thorsten, no?
That's Thorsten. This guy has his blog is good. That's what I was talking about. Not his books. Yeah, sorry. His Twitter is also really good. And he works as a database company, so he obviously knows what he's talking about. So
Yeah. What I was thinking was there was like a point he was trying to make, but this is more like a
as a
discussion kind
compare
of
and
thing.
contrast. Yeah. So,
Sorry.
yeah. By default, it gives you a level of awareness of allocations you just can't get from typical Go or Rust code, depending on the project's practices. Perhaps it's possible to switch off the Go, Rust, and C standard library and use one where all functions that allocate require an allocator. But explicitly passing allocator is still sort of a visual hack. I think the ideal situation in the most will be that every language supports annotated blocks of code as must not allocate or something on those lines. Either the compiler will enforce it, and I think this is a good thing, right? Like if you have an attribute, I think in Rust you can do something like I don't know if you can do it, but like attributes have a way of you can have like a macro or something that says that this function does not allocate, and then the macro will basically try to do this. I don't know if I don't even know if this is actually possible, but I can see where he's going with it, right? Like if you can annotate the piece of code saying that this allocates memory, I think it'll be easier, right, for you to just catch it in compile time. So the compiler will force this and fail if you seem to allocate in a block marked as must not allocate, or it will panic during the runtime so that you catch it in tests, right? This would be useful beyond static programming. It would also be interesting to allocate blocks in JavaScript as or Python as must not allocate. It's actually an interesting idea. Someone should build a compiler. We already have like 10 different runtimes that are happening every day, so someone should build this into their runtime. Right, every other Thursday we see a new JavaScript runtime, so someone should do this.
Good idea.
So otherwise, the current state of things is that you would normally configure this sort of thing at the global level, saying that there must not be any allocations in this entire program. Just doesn't seem as useful in generally saying that there must not be any allocations in one block. I guess so. Optional, not required allocator arguments. Rust has nascent support for passing an allocator to methods that allocate, but it's optional. From what I understand, C++ str is like this too. I don't know. I can't comment about that. These are both super useful for programming extensions. This is one of the reasons I think Zig makes a lot of sense for Postgres extensions specifically. So what I am seeing, again, there's another article. I don't know if it's an article. It was a repository where they had written Postgres extensions. I think you used to be written mostly in C++ or C, and Zig is now folks are writing Postgres extensions in Zig, right? Because it was only always ever built for running an environment with someone else's allocator. Praise for Rust, Zig, and Go tooling. All of these three have a really great first-party tooling, including build systems, package management, test runners, and formatters. The idea that the language should provide a great environment to code makes things simpler and nicer for programmers. That makes sense. This is actually good. So, what Cargo has in terms of test runners and formatters, package management is really good, right? And you wouldn't expect I think for a systems level language, I think that's it's something that you are used to in like other languages, right? But even in JavaScript, there's no opinionated way of doing it, right? Literally for running tests in Node you need to use an external package, right? You need to use Jest. For formatter you need to have another tool. For build system you need to have another tool. So all of the, and for package management, literally I saw that Node is actually removing npm from its default package management. So I
What?
think the next versions of Node will not even have npm within it, right?
What will it have then?
Nothing. You'll have to install it
Then
yourself. That's what
okay.
I'm reading. Yeah.
Sure. Okay.
Yeah.
Yeah.
That's what I'm reading.
सही है.
I don't know why. I read somewhere. That's the thing, right? This is a very hard thing to search.
No, you won't get it.
Yeah.
नहीं, Google
I
won't
found
give
it.
you that.
Found
Oh,
it.
nice.
It's on Twitter though. I saw it on Twitter.
Algorithm in favor. Algorithm in favor.
Okay. I don't know. So I saw someone say this. I might be wrong.
Mhm.
Okay, so they're saying they are not going to remove it. Okay, fine. Great. I saw someone. I think I just misread someone's opinion as it should be removed, and then took that as what is happening.
It will be okay. No issue.
So I guess it's not getting removed. I think that's just
But
because
the point
people
is
are.
fair. If the ecosystem is nice, the at least the base tools that are given to you,
Yeah.
if they are of a decent quality, it makes it a lot easier for anyone to get up and
Yeah,
going with the language.
just has its own set of problems. Literally
Mhm.
having a test runner in your like in Rust, it's super easy where you can write a function and then you can just have an attribute. It's called hash test, and then you can basically start writing tests for the same function, same in the same file. You literally have your unit test, the same file as your code, right? It's you don't even need to have a separate file, right? And it makes things so super easy. If from what I've used, I think we'll get there. In JavaScript, this is new guy called Biome, right? They are hitting this problem. They're trying to do that all in one. And again, I'm reminded of this XKCD thing again and again, right? There are
Yeah.
12 standards. I'm
Different.
going to build a new standard. Now there are 13 standards. Yeah, so I'm just reminded of
But
that again and again.
if you don't have a inbuilt support, at least the current standard for it should be
Yeah. This is
considered for
this
official
is what I was
support.
talking about. There are 14
Yeah, yeah.
competing standards. We need to develop a universal standard that covers everyone's use cases. And then the situation is that there are 15 competing standards, right? Because all of those 14 came in with the same idea, right? And eventually you can't do the same. Right? It's very difficult to do. So yeah.
Last meandering non-conclusion.
Yeah. Let's just finish this. Where is it? Use the language you want to use. Zig and Rust both have nice alternatives to writing vanilla C. On the other hand, I've been pleasantly surprised writing Postgres C. How high level it is. It's a separate language since you have, okay. We're often dealing with user facing construct like Postgres datum objects, which represents what you may think of as a cell in a Postgres database. I did not know this was a thing. I guess I have to learn about that. And as you can, and you can use all the same functions provided by PostgreSQL for working with datums, but from C. Okay. That's nice. I've also, so it's basically I'm thinking as an abstraction on top of C in some sense. I've also been able to work a bit on Postgres sections in Rust with PGRX lately, which I hope to write about soon. And when I saw PGRX for PGZX for writing Postgres sections for in Zig, I was excited to spend some time with that. I guess that's the end of the article. Yeah, we can discuss a bit if you have any thoughts.
What do I get from this article?
Uh,
I got the allocator concept.
you
from
get
Zig.
you understand that all of these have different trade-offs and you pick what you want.
Yeah. I got that, but
It's not meant to give you a takeaway, right?
no, I was thinking like, where will I be able to use something from this?
Where will you
All
be
of
able
these are
if you,
just like,
once you start writing any of these
yeah,
languages,
I
maybe
don't write either of these languages, right? Like
that's
that's the
probably it,
issue.
right? Like so now there's okay. The takeaway is you should
But
now
it's
try
fair,
these
like,
languages. I should try these
yeah,
languages, right? So when you're stuck with a particular language, right? To be very honest, when the moment I started writing Rust, right, that you understanding memory management to some sense actually helps you write other languages also. You are now
better. Yep.
more aware or wary about your allocations. You are more wary about
Mm.
whether this how costly this operation is, right? uh,
And
s-
it discusses opinionation that has happened in this language in a fair criticism.
right.
It tries to offer up how the ecosystems of the languages
Right,
are
right, right, right.
structured,
And,
and
and
it makes
basically
things.
they're trade-offs, right? The trade-offs
Yeah.
here is being versus standard library versus a good community or like a dependencies on community packages, right? And quirks of the language, right? If you, I mean, if they had JavaScript in the mix, right? Just talking about that quirks would take another 2 articles, right? But
Mm.
they have all of these languages are all good out of the box. They don't have too many things to complain about. So I think the article is basically trying to just compare and contrast on the bits that vary, I would say.
Yeah, on the opinionation part of
Yeah,
these languages. Mm.
I think overall good article, I would say.
Good article.
But I think this
Yeah.
wants me to write more Zig or just try and learn more Zig, I would say. I probably still stick to Rust for most things if I'm building something. But I think just taking a good look at Zig is something that I should do.
One thing that's like good to know is the last point, that even if you do try, you can, you should be having a good time writing these languages,
Yeah.
because they are supposed to have a lot of things that are inbuilt. And
So
one
yeah,
of the
so
things that,
you,
like,
you
one of the
cannot
pain
say that
points of
same
it,
thing for Rust initially, right? Like because a lot of these
yeah,
concepts are very like the Bora checker
new.
it's a beast of its own for someone who's coming from like a language like Python or JavaScript, right? It's not something that you are used to thinking about at all,
Mm.
right? But it takes a fair bit of learning. There is a learning curve. It's a fairly steep learning curve, but I think once you see what they are trying to do, they are trying to it sort of I guess like with the analogy that I've put myself to thinking is the Rust compiler is the best friend, right? Like the kind of the best friend that sort of looks out for you, like tries to uh, uh, catch errors before you do them, sort of, right? Not throw them on the runtime full. So those sorts of errors is something that Rust tries to avoid for you, and for that it comes at a cost of the steep learning curve. Maybe I don't know, sir, 5-6 years down the line, things might smoothen out. You might see it things much more approachable.
I
But
don't know where I heard this analogy, but uh, I probably a no boilerplate video, but I remember hearing that many functional languages are trying to solve this concurrency problem by targeting the uh, mutability of a data object
yeah, yeah,
point. Like,
yeah,
you make it immutable,
yeah, yeah,
and other functions can read it,
yeah,
and you could confidently say that this data has not changed.
yeah,
But the way that Rust tries to solve it, that is that everybody will be able to read it. I'm not sure if this is true. Like, I'm trying to remember. Everybody will be able to read it, but only one function or one instance of a function will be able to change it, and that control is given to some other function, and that is being passed on, and that's what the borrowing and checking is
correct.
about.
Yeah,
Yeah.
that's about true, right? Like you can have a mutable variable, but again, it's everything is immutable by default. Again,
Mm.
the same decision Rust has. But when you're talking about mutable borrows and like when you're trying to do mutable borrows, only the owner can change that, right?
Only the owner can change it.
So one of the reasons why that works well is if you're looking at in a concurrent system, right, where you have multiple threads trying to change something, you this sort of tries to completely get rid of data races in some sense, right? Like you cannot
Mm.
have data races if you have a shared resource of some sense, and then you're trying to have two threads trying to update that resource. It's unless and until you put that in some sort of a locking mechanism or a synchronization mechanism, the compiler will not allow you to do it, right? So by default, right? And those are some guarantees that Rust gives you out of the box, and for that the trade-off is slightly it is syntactically slightly different also in some sense, right? Not it's not very different like writing a function language, right? It's but you just have to jump through a couple of hoops to the point where you reach there, right? I would say, right?
Do you
Like
have a cons in Rust, like a cons operator?
const.
Cons, cons.
What is cons?
It's like a mathematical equal symbol. It's a concept in uh, Haskell and OCaml probably either one of these. But it's a modified version implemented in Elixir, wherein it is called pattern matching. But
Oh, so pattern matching, yeah, that you have in Rust, but I don't know if you, I don't know
can
how
you
that.
can you look up cons operator in Rust versus
That,
pattern matching?
yeah, pattern matching in Rust, you have a match keyword, right? Uh,
Yeah, Lisp also contains it.
I don't know. I'm not sure if that exists in Rust. Yeah, so okay, does not have anything in Rust. You don't have anything
Okay.
like that. Yeah, you
Okay.
don't do
Got
things like that, I guess. But if you pattern matching Rust is good. It's basically a really good switch case, but you need to have all the cases covered, right? It's a switch case on like it's a perfected switch case, I would say, right? So you'll have to
Match
handle
dot
every
number.
yeah. So match. I think Kotlin also has a very similar syntax. Kotlin also has the same match keyword if I remember correctly, right? And so I think this is really powerful. You can do a lot of this with match expressions. I actually like this. I prefer this if JavaScript had this, this would be really nice in
Look
contrast
up
with us.
cons. Look up cons in Scala. I was
I
incorrect with the language. It was cons in Scala.
okay.
Yep. To
This
the Stack Overflow one.
has two subclasses. Cons is a class. It can be created by its constructor as well. Okay. So you can do this and then.
Yep.
So Rust uses
Kind
this
of like
for
that.
yeah. Rust uses the same operator, but it doesn't use it for this specific use case. It uses it for like
Case switch
yeah
cases.
yeah. I know it is used for like methods and things like that. Like if you want to call like how do I so say for example you have a struct like if you have a mod if you have a module, right? Like if you want to import something from that module, you probably use this to get that, right? So this is how they're using. So if you want to call a function from a specific module, they use this operator, for example, right?
It
But
looks
not
like the jump won't be that far and difficult because these concepts are already being like I've already been reading up on these concepts. And,
yeah, yeah.
it isn't-
For me from someone who's writing TypeScript every day, the syntax was not that different. But like all the semantics, memory semantics is what takes a lot more time than syntax, I would say.
Can you show an example where that is heavy?
Generics is
Like,
probably where you would have, or generics or lifetimes. Not even generics. I would say lifetimes are where the, um, but the Rust book won't have all of that syntax, right? Usually,
okay.
it's most likely going to be straightforward thing. Um, yeah, yeah, so you'll see this a lot. This means a static lifetime, right? I think the moment you have static lifetimes is when you would start seeing that syntax a lot, like slightly
Okay.
vary syntax, I would say. But again, that also you'll get used to. But and writing macros are also slightly difficult, like proc macros, procedural macros, or what they call. Those are also syntactically very heavy. I can show that. So let's say, right. So yeah. So here,
Uh,
so this is syntactically a little bit heavy, right? So you don't know what A is. If you look at it, you don't know what A
yeah.
is, right? So you have a bunch of A's that are looking here, are seen here, right? So, but what A here means is that this particular variable, right, is it tells the borrow checker that you need to keep this variable alive for a specific scope, right? So say for example the scope here is borrowed, right? So this ampersand x would take in as it'll take it'll you need to have this ampersand x as long as this scope exists of some sort. I think lifetimes it's a whole thing. It's an annotation. It just tells the compiler that you don't have to worry about this particular variable because I know that this the scope is from here to here or something like that, right? So that's what lifetimes are.
Interesting.
But yeah, I think we will look at this deep dive, or maybe look at a Rust introduction if everyone is interested. We can look at it. But
How are
sometime.
you learning Rust right now? Like you can stop the recording if you want. Like,
Yeah. But, yeah. I'll finish this one and then we stop the recording really quickly.